Okay, I'll talk about the question 37 in chapter 4. This is about an article that in a journal describes several experiments investigating the rotting of concrete to remove entrapped air. A 3-inch diameter cylinder was used, and the number of times this rod was used is the design variable. The resulting compressive strength of the concrete specimen is the response variable. The data are shown in table 4E5. So I'm going to show you the data set. This compressive strength data for exercise 4.37. We have the rotting level 10, 15, 20, and 25. These are the treatments, another way of saying it, or levels, another way of saying it. And the corresponding compressive strengths are as follows. For rotting level 10, we have 1530, 1530, etc. For each level, we have three given compressive strengths. First question is there any difference in compressive strength due to the rotting level? Answer the question by using the analysis of variance with alpha 005. B. Construct box plots of compressive strength by rotting level. Provide practical interpretation of these plots. Part C. Construct a normal probability plot of the residuals from this experiment. Does the assumption of a normal distribution for compressive strength seem reasonable? That's it. So the way we already uploaded the data set. We are going to go to stats. We are going to go to ANOVA. This is going to be one-way ANOVA. This is going to be ANOVA because we have more than 2 populations to deal with. So we have 4 levels here. One-way ANOVA. So in here, I already did that before actually. Response data are in one column for all factor levels, or response data are in separate column for each factor levels. Okay, let's try to see the data set first. C15 and C16 are the data sets we are interested in. So the way that it's written, the data set is level 10 we have 3 inputs. For level 15 we have 3 inputs. For level 20 we have 3 inputs, and 25 we have 3 inputs. So the response variables are in one single column. So according to that, we are going to choose the first one. Response data, response variables are in one column for all factor levels. So therefore, I chose the response as our response variable was this C16. So I chose that, and the factor levels were entered in C15. So I entered that. Now I can redo that if you want. So for this factor level, factors, C15 is the one, so I select in there. Okay, this is all similar in any Minitab file. We entered the data set as follows. And then I want to see the graphs, because later on it asks about the graphs. Okay, I want to see the box plot, because it says construct box plots of compressive strength by rotting level. So I'm going to click that, and then I'm going to also draw, it asks about the residuals in part C, I guess, yeah, normal probability plot. So I'm going to choose the normal probability plot of the residuals here. Okay, maybe in the future, so these 4 are going to be useful for checking the assumptions. So maybe in the future you're going to do 4 in 1, and it's going to show all these 4 in 1. But for now, for C, we need that. And that's all to it. So I'm gonna just click on that. I'm gonna click OK to get the results. Okay, so I'm gonna discuss these later on, but I want to talk to you about this screen first. This is the session. If you want, I'm gonna send this to the Word right away and talk about it on the Word file. And I'm gonna also send this normal probability plot as an answer to B. I'm gonna send it to Microsoft Word, and I'm gonna close that. And then box plot, I'm gonna send it to Word as well, and I'm gonna talk to you about it afterwards. And close it now. Okay, and there's this also interval plot. Let's send it to Microsoft Word. And it should be it. Okay, so if you open up that, so we can see everything in here in our Word file. Maybe the orders are not the right one, because I think in part C it's asking about the normality, so this is, I took it first. Okay, okay, let's see, what is this for? Okay, this is done twice, I guess. Okay, it already did, but I did. Okay, sorry about that. So once you send it from the menu, so it's gonna send all of them once, so you don't have to do it each one separately, which I did, so it wasn't the right one. Anyway, so so this is a summary of our ANOVA test. Null hypothesis was all means are equal, all means of these routing levels. Okay, mean of this, mean of this, mean of this, mean of this, mean of all levels are equal, or alternative hypotheses are not all means are equal. So at least one of them is not equal. Okay, significance level is alpha 0.005. We assume equal variances because there is no information about this, so we can, to make it simple. Factor information, here it is, there are 4 levels, which is 10, 15, 20, 25. And we get that from this data set. Analysis of variance, degrees of freedom, for the road levels, there's 3 of them. Okay. And there's p-value, it's given here. For the rest, we don't need that as much for this question. And means for each road levels and their confidence interval with respect to alpha 0.005 are all given here. The means and standard deviations, etc. Okay, is there any difference in comprehensive strength due to the routing level? For this, we are going to go to p-value. You see the p-value. P-value is much bigger than alpha 0.005, so we are going to say that we failed to reject null hypothesis, which means null hypothesis was all means are equal. So our result is all means are equal, which means there is no difference in comprehensive strength due to the routing level. So that's our answer to part A. Answer to part B. Okay, construct box plots. Okay, let's read that. A strength by routing level, provide a practical interpretation of these plots. So we'll get the, okay, we go down, yeah, we go down for box plot. This is interval plot, this is the, we don't need that. We need the box plot, so we'll get these box plots for each level, level 10, level 15, level 20, level 25. And as you see, 20, 15 and 10, it shows the variations according to the levels 10, 15 and 20. But when you look at the 25, the variation is not too much, so it's very little variation here. So that's all we can say about this plots. And part C, in part C, what's part C? Construct a normal probability plot of the residuals from this experiment. Does the assumption of a normal distribution for comprehensive strength seem reasonable? So we look at the normal probability plot with respect to the residuals, and it lies around this line, so it is reasonable to assume that the so we construct that. Okay, so it's reasonable to assume that in normality here. Okay, and that's it, and it's the end of the question.